Okay, here we are for part 2 of looking at how do you write an equation for an ellipse and how you figure out the key information of an ellipse from the equation. So in our first video, if you haven't seen that yet, make sure you go back and check that out. I don't know why we zoomed out there, but anyway, if you have not seen that first video, definitely make sure you check that one out first. That is the introduction to ellipses and looking at the more simplified equation first. So this one brings in the idea when you have an ellipse where its center is not at 0 or not at the origin. So you should notice the difference from the previous equation to this one is now we have these components in here with our x and y, which makes it even more similar to a circle. So if you can go back and look at that circle video if you're a little bit confused on that, and that'll kind of show you where this is coming from with the h and k. Specifically, whenever you have that, where you have an ellipse with these numbers with x and y inside of your perfect square there, then that is going to give you your information that you need to identify your center point. And that works exactly like a circle. So whatever you have inside of with your x, it's the opposite of that becomes the x component of your center. And the same thing for your y. Whatever number is in there, the opposite of that will become your y component of your center. All right, and then the a and the b still works to help us figure out our distance away from the center to get your vertices for your major axis and your minor axis, and also helps you figure out your focus points. So we're going to look at this problem that I've got here where there's a little bit more going on than we had in the previous video showing about an ellipse. This one looks like it has quite a bit going on, in fact. So let's dive right into what we can figure out. So the first thing I noticed when looking at this equation is I have an x squared piece and I have a y squared piece. And just knowing that and just looking at that, you may say, well, you know, that could be a circle. And you're right, it could be. Remember that a circle and an ellipse are very similar, with just a little difference in that the ellipse kind of looks like a circle that someone has squished a little bit on one side. So we'll have to see how this plays out in just a second. The bigger thing that I notice is that I have some x parts, I have some y parts, and then just a regular number. So in working with this and thinking about what this is going to look like as a graph, I'm going to try to work towards putting this equation somewhat in this kind of format. And we talked about this on the video with circles. To do this, I need to be able to create this group here of a perfect square. Same thing for the y's. So to kind of work towards that idea, the first thing that I'm going to try to do with this equation is group things that belong together. So the first thing, let's rewrite this putting our x pieces together. So I'm going to just rewrite 4x squared plus 24x. And then I'm going to skip a little bit of room here and put y squared minus my 2y, just kind of giving me some room to work. And I'm going to take this number that's just a constant and move it over to the other side. Because whether it's a circle, whether it's an ellipse, the regular numbers, the constants, I do need over on the other side of the equation. So if I move that over, then that would be a negative 21. Okay, so now thinking about this, this is where, again, I'm going to refer back to the circle video. We're going to try to create this perfect square trinomial. And if you'll refer back to that, to do that, I have to put a number here that will create that perfect square trinomial relationship. And the way that works is you take half of the middle number, as long as there's no coefficient in front of y squared, you take half of the middle number, so half of negative 2 would be negative 1, and then I'm going to square that. So if I square negative 1, I would get positive 1. Okay, got it. Now, in this one, we got to do a little bit more work. And the reason why, whenever we did it here, notice that I refer to as long as there's no coefficient here other than 1. In this one, we do have a coefficient other than 1. So that creates a little bit of a dilemma. We need to deal with that first. I would much rather this problem look like this one so that it's much easier to work with. So to do that, I'm going to factor a 4 out of these two terms. And if I do that, then this would become x squared plus 6x. And then I still have the other stuff here that we just did. And let me just kind of write this in blue again so we can see that that was a new addition. Because we're going to have to deal with that in just a second. So now in figuring out this third term, following the same idea, take half of the middle, which would be a positive 3, and then square that would result in a positive 9 here. Now, just like when we had the circle and we did the same process there, the parts that I have written in blue, those are new additions to this equation. They were not originally part of the equation. So I have thrown off the balance of this equation. It's not like it was originally. So to keep that balance, whatever I do to one side of the equation, I have to do to the other. So I put in a plus 1. I'm going to put in a plus 1 over here as well. I put in a plus 9 here, but I'm not going to put in a plus 9 on this side. The reason why is because whenever I put this plus 9 in here to create this perfect square trinomial situation, you have to notice that this plus 9 is actually getting multiplied by 4 on the front, or on the outside. And you can kind of see that in these other two. This is not really an x squared. Whether it's written that way here, it's 4 times x squared, which is really 4x squared. This is not really a 6x. It's being multiplied times 4, so its overall value is 4 times 6, or 24x. Similarly, the 9 that I wrote in here would not really have a value of 9 overall. It would have a value of 4 times 9, which would be 36. So by writing in that 9, I have created this value of 36, so therefore I have to do that on the other side as well, a value of 36. So now that we have that, we can try to start breaking some things down. Okay, here we go. Let's check this out. So I would have 4. This is a perfect square trinomial of x plus 3. Remember, half of that middle term is what comes here. If you square it, it gives you the 9. Everything works. This one would be the perfect square of y. Whoop, messed up there. Should be y minus 1. Squared, again, because it's half of that middle term. And then at the end, negative 21 plus 1 plus 36. Well, a negative 21 and 1 would be a negative 20. Negative 20 and 36 would be a positive 16. Okay, so at this point, you may say, well, is this a circle? What's going on here? Well, it could kind of lean to be a circle, but what I notice is that we have a number in front here, and that's going to throw some things off. Also, remember earlier in the previous video, I said that when you have an ellipse, the number over here at the end needs to be a 1 so that everything works correctly. I don't have that. I have a 16, but that's easy to fix. I can simply go through and take the 16 and divide everything by 16. If you do that, then our new problem, I would have 1 over here. Over on this side, 4 divided by 16 would reduce to 1 over 4. Same thing here. Nothing's going to reduce on this one, so that's just going to be y minus 1 squared divided by 16. And see, now that's following that format that I just had a second ago of that ellipse. So it takes a little bit of practice to learn how to recognize, is it going to be a circle, is it going to be an ellipse, what's the correct format. But with practice, it definitely does come easier. Okay, so now what we want to do, that we have our equation, we want to figure out our key points, our key information. So first of all, where is the center of this circle, or not circle, where is the center of this ellipse located? Remember, it's going to be the opposite of these numbers with x. Well, did not want to do that. So I can get that. There we go. Opposite of these numbers in here. So that would be the opposite of 3 would be a negative 3. Opposite of negative 1 would be a positive 1. There is my center. Okay, what about my vertices? Where are they located at? Now, before I do that, what I want to do is just kind of think visually on this for a second. So this ellipse is located at negative 3, positive 1. So negative 3, positive 1 is the center of this ellipse. What I also see is that my bigger denominator is over with my y's. And since the bigger denominator is with my y's, that's telling me that this ellipse is going to be stretched out somehow like this, vertically versus horizontally. Okay, so my vertices are going to be at the top and bottom. So I'm going to treat this like my A and this like my B. Remember, A is the bigger number. So in that case, I want to take this number on the bottom is a squared. So I need to know what a is. So if a squared is 16, that means a is 4, which means that this point of negative 3, 1 that I have here, I need to go up 4, and then I need to go down 4 in order to figure out those vertices. So if I'm at negative 3, 1, and I go up 4, then that vertex would be at negative 3, 5, going up 4. That's only going to change the y component. Then if I go down 4, then that would become negative 3, negative 3. So I have this point negative 3, 5. I have this point negative 3, negative 3. Okay, I can also figure out the vertices on the minor axis. That's going to be related to the b value, the smaller one. So if this is b squared, then b would be equal to 2. So if I go right 2 and left 2, I can figure out those other minor vertices if I wanted to know that. In this case, if I go right 2, then that would become negative 1, positive 1. This one, if I go left 2, would be negative 5, positive 1. Again, this time I'm just changing the x-axis of that center point. And finally, we want to know about the two vertices, I'm sorry, not the vertice point, the two focus points. Remember that your focus points are tied in with your C part, and your C part we can get from this formula. So if I plug that in, here's a squared, here's b squared, so I'm going to do 16 minus 4. 16 minus 4 is 12. If that's the case, then C would be equal to the square root of 12. Okay, so let's figure out our focus points. Our focus point is going to be this amount from the center. Okay, so it's going to go up this amount of square root of 12. So if that's the case, then it's going to be negative 3, and then 1 plus the square root of 12, whatever that might be. And then it's going to also go down, so it's going to be negative 3, and then 1 minus the square root of 12. And then there we have it. That is our key information. So you can see this, it works really similar to working with circles in terms of strategy. And then once you ever get down to the equation, it's just a matter of breaking down what's your A, what's your B, figuring out how that relates to your center, and from there you can find out all your other key parts. Just remember that your A always relates to the biggest number. B is going to be your smaller number. So it's not that A is in a fixed place. A is not always with X. A is not always with Y. A is your bigger denominator. Or A squared is your bigger denominator, rather. Okay, hope that helps. That is ellipses. That's our wrap up. Hopefully you're good to go. We'll see you next time. Thanks.